Hi guys, I'm going to take a seminar about applications of mathematics in deep learning. And let's begin coming with the introduction. Deep learning is a subfield of machine learning and artificial intelligence that is based on the artificial neural networks. Deep learning is an algorithm uses multiple layers of neural networks to model or solve and complex problems such as image and speech recognition, natural language processing, and autonomous vehicles. Deep learning has realized many fields including computer vision, speech recognition, natural language processing, and robotics. Its applications range from image and speech recognition to medical diagnosis and the drug discovery, and it is made used in many industries including healthcare, finance, and entertainment. However, deep learning also faces many challenges such as need for the large amount of the data and the potential for the bias on network training data. Nonetheless, it remains a rapidly evolving field with the potential to transform many aspects of our lives. So, coming with the deep learning main topic, which is deep learning is a subfield of machine learning and artificial intelligence that is based on the artificial neural network. The main idea behind the deep learning is to create models that can learn and make decisions in a way such that which is similar to the human brain. Deep learning models are typically made up of the multiple layers of artificial neural networks, which allow them to learn and they extract increasingly rapidly complex features from the raw input. Uh, one of the primary advantages of the deep learning is its ability to work with an unstructured data such as images, audio, and natural languages. So supervised learning involves in the training at the model level data, while unsupervised learning involves in the training the model and the unlabeled data, and they evolve in allowing it to discover patterns and the relationship on its own. Deep learning has many applications in variety of fields, including computer vision, natural learning processes, robotics, and healthcare. Some of the examples of deep learning uh, and applications include image recognition and the object detection, speech recognition and natural language processing, autonomous vehicles and robotics, predictive maintenance of manufacturing, medical diagnosis, and the drug discovery. While deep learning has shown a great promise in many areas, it also presents some challenges such as need for large amount of training data and the potential for bias in the training language. Nonetheless, deep learning continues to be a rapidly evolving with the potential to perform on many more aspects like in our lives. So next coming with the conventional neural networks which are known as CNNS. CNNS are the type of deep learning neural network that are particularly well situated for image recognition and the classification of tasks. They are inspired by the structure of visual cortex in the brain and consist of multiple layers interconnected neurons like that learn to interact and extract increasingly complex features in the image output. CNNs are typically also include pooling layers, which down the sample the feature to maps reduce their size while perceiving their essential information. Finally, the output of CNN is passed through a one or more successfully connected layers that perform a classification of tasks. CNNs have achieved the state of art of performance in a wide range in image recognition and the classification of the tasks, including object recognition, face recognition, and the medical image analysis, and other among. So next is the recurrent neural networks, which are known as RNNs. RNNs are a type of a neural network that are designed to work with a sequel and sequential data, such as the time series data and the natural language text. They are able to process the variable length sequences of input data by maintaining an internal state or memory that allows them to capture dependencies and the pattern across the time or sequel. One of the among RNN is the long-term memory, which is known as LSTM network, which is designed to avoid the problem of vanishing gradients that can occur in traditional RNNs. LSTMs have a more complex architecture that includes gates that control the flow of information and the forgetting the previous stage. RNNs have been used to in a wide range, include the recognition of machine learning, segment analysis, and the image captioning, among others. They are also particularly useful for tasks and they involve in the sequential data, while others are other data are important. And next, going with the generative adversarial networks, which is known as GANs, are a type of deep learning neural network architecture that is used for generating new synthetic data and that resembles the original training data. And GANs consists of two neural networks or generator and a discriminator. So the generator network is trained to generate the synthetic data and that resembles the original training data, while the discriminator network is trained to distinguish between the synthetic data generated by the generator and the real data from the training set. The two networks are trained from the adversarial manner, meaning that meaning and the meaning of the trained of the complete against each other. And next, going the goal of GAN training is to find the main point of the generator, produce the synthetic data that are indistinguishable from the real data, which are the point of generator that can be used to create a new data and reassembles the original training set. GANs are the tasks including image and video synthesis, text generation, and the generator, among others. So, however, they can be difficult to train and they can suffer from the instability and the mode collapse. And next, going with the autoencoders. Autoencoders. Autoencoders are a type of a neural network that is used to supervised and unsupervised learning, particularly in the domain of the data compression and the representation learning. The goal of autoencoder is an learn a compact and representation and or encoding of a given output in data. So the during the training, the autoencoder is fed with the input data and the loss between the original input and the reconstructed output in this calculator. The network parameters is just to adjust the minimize of the reconstruction loss and effectively to compress the decompress the input data. So variations of autoencoders include in the denying the autoencoders and variational and autoencoders and the de-adversarial autoencoders. These variations introduce additional contexts and objectives to the autoencoder architecture, allowing more complexes in the representations to be learned. And next, going with the reinforcement learning, which is also known as RL. This is a type of machine learning technique that involves an agent learning to make a decision by interacting with an environment in order to maximize the cumulative reward signal. It is based on the idea of the trial and error learning, where the agent learns from the experience of interacting with the environment. So the RL is a process which involves in three keys of the components, which are known as the agent, the environment, and the reward signal. The agent takes the actions in the environment based on the current state and receives feedback in the form of reward signal. The agent is to update its policy based on the feedback and thus the process repeats. RL is applied to a wide range of tasks including a game playing, robotics, and the autonomous vehicles, among others. So Q function is based on the reward signal received. Other algorithms include policy gradient methods, actor critic methods, and the deep reinforcement learning algorithms that combine RL with the deep neural networks. And next, coming with the applications of deep learning. Deep learning is a subset of machine learning that involves to use an artificial neural networks to process and learn from the large amount of the data. Here are the few examples of deep learning applications. So first one goes with the image and speech recognition. Deep learning algorithms are used in image and the speech recognition systems. The next one is natural image processing, which is known as NLP. Deep learning algorithms is used in NLP systems to understand and interpret and generate human language. And next one is self-driving cars. Deep learning algorithms are used to produce power to the computer vision and decision making system of the autonomous vehicles. And next is with the medical diagnosis. Deep learning algorithms are used in medical diagnosis to accurately analyze the medical images such as CNTs, MRIs, and X-rays to detect issues and diseases. And next, coming with the fraud detection. Deep learning algorithms can be used to analyze the large amount of financial data and detect fraudulent activity. And next one is robotics. Deep learning algorithms are used to detect the robotics and recognize the and respond the different objects in the environment. These are the few examples of how deep learning has been used in different industries and different fields in day-to-day life. And next, coming with the conclusion. In conclusion, deep learning is a powerful subset of machine learning that involves in the use of artificial neural networks to process the learn and the from the large amount of data. It has revolutionized the field of artificial intelligence and has enabled the development of artificial intelligent systems that can be recognize patterns, make predictions, and learn from experience. Deep learning has numerous practical applications, including image and speech recognition, natural language processing, self driving cars, medical diagnosis, fraud detection, and robotics. As technology continues to advance, it is likely that deep learning will continue to play an important role in the shaping of our future, and it is an application only where we can expand and evolve. Thanks for watching this video, guys.